previous two video, I had discussed about induced metric with examples. I had discussed different type of example of metric space which had come different type of comparative exam. Just recall the question again because this type of question are very important for any comparative exam. Actually, this is not only example, this is just property. I had seen, just recall, I had seen if D and D dash be metric on Rn, then the induced metric which is denoted as D star which is equal to D plus D dash be metric on Rn. That means if D and D dash be metric on Rn, then our construction sum of these two metric is also again be metric on Rn, which I had discussed in my previous video. But today I will just use this example as a property. But at first I will highly recommend you, if you don't see my previous video, at first see my previous video. Second, I had seen if D and D dash be metric on Rn, then any scalar multiplication of the metric is also metric on Rn. Also I had seen if D be metric on Rn, then any scalar multiplication be metric on Rn. And the construction is such type, if D and D dash be metric on Rn, then construct a induced metric D star double star equal to such type K dash D plus K double dash D dash, when K and K double dash be any positive number. This is also be metric on Rn. And I have just multiplied any metric by any scalar and then add them. This is also be metric on Rn. Third, D over 1 plus D. I had seen in my earlier video. This is also be metric on Rn. But if we consider D of xy equal to minimum of x comma y, then this is not metric on the set x, because consider minus 2 comma 3, then minimum of minus 2 comma 3 equal to minus 2, who is less than 0. Therefore, this has broken the rules D of xy greater than always greater than 0. So D of xy equal to minimum of x comma y is not metric on x. Fifth, D of xy equal to absolute value of x to the power n minus y to the power n is not metric on x if n is even. This is our rules. These rules are very important for any competitive exam. Just one example which had come CSIR net December 2016. The construction is such type, let D1 and D2 be following metric space on Rn. Here D1 denoted as just one metric, summation I equal to 1 to n absolute value of xi minus yi, and D2 denoted as just two metric, summation I equal to 1 to n absolute value of xi minus yi whole square to the power half. Here this is metric as D1 and this is metric of D2. Then decide which of the following is a metric on Rn. First option, d of xy equal to d1 xy plus d2 xy over 1 plus d1 xy plus d2 xy. Is it correct option? Notice I have seen d star equal to d over 1 plus d always be metric space on Rn. That means metric over 1 plus metric is always metric space on Rn. If we all of us know sum of two matrices is always metric. So obviously this d1 xy over plus 1 plus d of xy is always be metric space. So this would be one new metric. Consider this is metric, new metric, and this is also would be one metric. So obviously metric over 1 plus metric is always be metric. So first option is always right option. And second option indicate d of xy equal to d1 xy minus d2 xy. Here minus. For this minus, this will break the condition d of xy greater than 0. That means this is not be metric on Rn. And third option, obviously true option, d of xy equal to d1 xy plus d2 xy always be metric on Rn. And fourth option, this is also used by the rules. D of xy equal to e to the power pi d1 xy plus e to the power minus pi d2 xy. Here k equal to e to the power pi and k dash equal to e to the power minus pi. I have told you any scalar multiplication of any matrix is always metric. So this is one metric and this is another metric, and their sum always would be metric space. So fourth option also be right option. That means option 1, option 3 and option 4 are right option. Are you getting how this property are very important? If you know this property in better way, then you will evaluate such type of metric space on Rn easily. Are you getting? Now I will see some example which are not metric space. I have indicated this example more and more times because actually this type of example are very important for all competitive exam. ITSM, GATE, NETs, for all competitive exam. So I have indicated this example more and more time. Here in each exam this type of example has come. First example, D be a metric space from x cross x to R such that d of xy equal to absolute value of x plus absolute value of y. Is this the metric space? At first verify it. D of xy equal to 0 imply obviously mod x plus mod y equal to 0. And mod x plus mod y equal to 0, that imply mod x equal to 0 and mod y equal to 0. And mod x equal to 0, mod y equal to 0 imply x equal to 0, y equal to 0. That means I have got d of xy equal to 0 equal imply x equal to y. Conversely, let x equal to y. Now multiply both sides by minus x. Then minus x equal to minus y, and from this expression x equal to y and minus x equal to minus y, we can write mod x equal to mod y. Okay? And from this expression we can tell mod x minus mod y equal to 0. And this does not imply of d of x comma y equal to 0. Because d of xy means mod x plus mod y. Are you getting? That means this d not a metric space. Second example, d of xy equal to mod of x square minus y square. This is also not metric space because d of xy equal to 0 means mod of x square minus y square equal to 0, and from this expression we can tell x square equal to y square, that means x equal to plus minus y, and x equal to plus minus y means either x equal to y or x equal to minus y or minus x equal to y or minus x equal to minus y. That means for these three conditions we can tell D is not a metric space, because for metric space d of xy equal to 0 always imply x equal to y. Okay, so I have told you d of xy equal to, if we take x to the power n minus y to the power n, this is a metric space when n equal to just odd number. When n equal to even number, then this not be a metric space. Okay? Oh well. Now consider another metric space. D be a metric from x to x, and the metric is defined as d of xy equal to maximum of absolute value x comma absolute value of y, and show that D is not a metric space. D is obviously not a metric space here also, because d of xy equal to 0 imply maximum of mod x comma mod y equal to 0. Means maximum of mod x comma mod y equal to 0, that means mod x equal to 0 comma mod y equal to 0, and mod x equal to 0 imply obviously x equal to 0, and mod y equal to 0 imply y equal to 0. That means that imply x equal to y. Conversely, consider x equal to y or minus x equal to minus y. That means mod x equal to mod y, since from this expression we can tell, and that imply maximum of mod x comma mod y not be equal to 0. Because as for example, if you consider 5 and minus 5, then their maximum equal to 5, not be 0. So maximum of mod x comma mod y not always be metric space. Are you getting? This type of example actually very important for any competitive exam. Now consider a metric space D from x cross x to R such that d of xy equal to absolute value of x minus y whole square. This is also not be metric space, because this will satisfy obviously positivity property, symmetric property obviously, but it will break the triangle inequality. For triangle inequality, consider 3 point x equal to 1, y equal to 4 and z equal to 6. Then by triangle inequality, we can tell d of x comma z less than equal to d of x comma y plus d of y comma z. That means d of 1 comma 6 less than equal to d of 1 comma 4 plus d of 4 comma 6. Now put the value here, then this would be 25 less than equal to 9 plus 4, who is less than equal to 13. But 25 less than equal to 30, this is 13, this is not possible. So triangle inequality has broken here. So this type not be metric on R. Now let's see similar type of example which had come GATE 2014 exam. The question is, consider D1, D2, D3 be matrix on the set X with at least 2 elements. then which of the following is not a metric on the set X? Option 1, minimum of the set D1, 2. Option 2, maximum of the set D2, 2. Option 3, D3 over 1 plus D3. Option 4, D1 plus D2 plus D3 over 3. Just at first think own self. Minimum of D1, 2. Obviously this is greater than equal to 0, and since D1 be a metric space, so D1 equal to 0 imply X equal to Y, and if we consider D1 equal to 0, then this minimum value would be equal to 0. Are you getting? And that imply X equal to Y. Similarly, here triangle inequality also will be satisfied. So this is be a metric space, and symmetry property also obviously would be satisfied. But notice, is it metric space? Maximum of D2, 2. Notice, since D2 be a metric space, so obviously this is equal to 0 imply X equal to Y. Okay? But when D2 equal to 0, then this maximum value would be 2. So, this is equal to 0 cannot possible. So, this is not be metric space. Are you getting? Because here the maximum value 0 here cannot possible. If we consider this is 0, then the value would be 2. And this is possible because this is the minimum value. If we consider this is 0, then this value would be obviously 0. And we all of us know third condition be always be true. And fourth, D1 plus D2 plus D3 over 3. This is be the linear combination of these three matrices. So obviously fourth option also right option. So 1, 3 and 4 be right. But here has indicate which of the following is not a metric space. This is only option 2. That means for this question only option 2 is the right option. These three are metric space. Now let's see one another type of example which had come CSIR net June 2019 exam. The question is, for alpha belongs to R, let box alpha denote the greatest integer which is smaller than or equal to alpha. We all of us know box function. Here the matrix defined as D from R cross R to close 0 open infinity by D of xy equal to box of absolute value of x minus y where xy belongs to R. Option 1, D of xy equal to 0 if and only if x equal to y. At first think own self. This is very easy type question. If we consider 2.0.5 and 1, then box of 1 minus 0.5 equal to, all of us know, box of 0.5, and box of 0.5 is actually equal to 0. And notice that here D of xy equal to 0, but 0.5 not equal to 1. That means option 1 is a wrong option. Also, since this option has broken, that means obviously this D is not metric space. So, option 4 is a right option. And D of xy always similar to D of yx. This is right option. Now I will see, is it verify the triangle inequality? Similar to before. For triangle inequality, consider 3 point x equal to 0, z equal to 0.5 and y equal to 1. And D of xy equal to box of x minus 1, this is obviously equal to 1. and D of exit would be 0.5, that means box of 0.5 equal to 0, and D of Z2Y also 0.5, this is box means 0, and that means 1 less than equal to 0 plus 0, that means equal to 0. This is not possible. So triangle inequality also broken here. That means this is also wrong option. That means option 2 and option 4 are right. Are you getting how we have to find metric space? Well, I will stop here. In my next video, I will discuss this topic also with some example, because I have told you this topic is very important for any competitive exam. See you soon. Stay safe and stay positive always. And don't forget to subscribe my channel for more videos. Thank you so much.